What you are seeing here is a set of functions connecting the x and y axes in the first quadrant with the special property that they all have the length equal to 1. If you don't trust me, you also see this quarter circle having a radius of 1 and not moving its radius at all. So today we'll be looking at the area under the graph.
Hey, welcome back to my channel. Today we will be integrating this function. As you can see, it's made up of these line segments. They all have a special trait. Namely, they have the length equal to 1 and they start at 0 to 1. So let's first define one of these lines. So we have a function in terms of x, but also equal to t, t being here, this is t. So of course we have to start at t, and then we have plus something of x. Actually, you can see it's negative because we have a negative slope here. And what we want is, let's see, we have t at the y coordinate, and then we have a special function. This is just a a circle with the diameter 1. So this has the function x squared plus y squared equal to 1. We can rearrange things in terms of y. So y is equal to the square root of 1 minus x squared. And because we have also we want the negative semicircle. And then we also have to add t to make it this point. So what we want is this intersection. This intersection is where this meets the y equals 0, the axis, and then only the positive part, but that's not relevant right now. So we are going to set these two equal to another. Oh, that's so disgusting. Okay, and we want to find out x. So first of all, move the t to the other side. So we have 1 minus x squared equals negative t. And then cube both things, make a negative to a plus. So then we can move 1 to the other side, and t minus 1, and now multiply with negative 1, and again take the square root of all of these. So that's our x value. This is namely the x value where this line should go. So now we have this triangle, we have this x value and we have this y value, and we can just use this as the slope. So we have to take delta y over delta x. This is y is just t, so that's t divided by, and then x, as we figured out, is square root of 1 minus t squared. So that's the function. Let me clean things up. Okay, so this is not actually the blue function, but just one black function. Let's call the blue function g of x, and we define it as the maximum for any t between 0 and 1, because this is 0 and 1, and then of f of x and this t value we just said. So to do this, we need to differentiate in terms of t and then plug in 0. So let's do that. I think that's the sign. I've never done this. F of x and t equals, so first of all differentiate, t is 1, minus, so that's x is a constant in the t world, so let's view this as t times this times 1 over this value. So first of all, differentiate t and keep this value the same. So that's just 1 over square root of 1 minus x squared. So 1. And then we keep the t but differentiate this value and add these, of course. So keep the t in the denominator because this squared is actually, well, we should use the chain rule. So let's differentiate that real quick. That's 1 over square root of x is x to the negative 1/2 power. Differentiating that is just negative 1/2 all times x to the negative 3 halves. So that's a function, and let's just rearrange this real quick. Negative 1 over 2, and here we get x to the 3 over second. That's right. So we get this plus is a minus actually, and we put in 2 times x. I just use x as a constant, that might be confusing, but I'm so sorry, this is a t. And we get 1 over 2 times square root of 1 minus t squared. And because this is 1/2 to the 3rd power. And after that we differentiate the inner function. This is t squared, negative t squared, so that's just times negative 2 times negative 2 times negative 2 and then t. So this 2 and this 2 cancel first of all, and yeah, that's it right now. Okay, so what we can do is we can try to pull out this fraction, but let's keep the left part intact for now and just worry about this. So this is a plus t squared over this. So what we can do is just write t squared over, and then we take one of this, so just 1 minus t squared, and the other one is just times 1 over, I'm so sorry, 1 minus t squared in the square root, because we have 2/3 is 1/2 plus 1. Okay, now we do pull out this thing, minus t squared, and then we get 1 for this, and plus t squared over 1 minus 2 squared in this part. So what we can do is just multiply the denominator, and I don't know English, by 1 minus t squared, so that we can put it on the same function part. So we get, okay, so these t's cancel, and we can just put it all on a fraction of 1 over t squared. So we have to multiply this by 1 minus t squared, this 1, and then this is just minus x times 1 over this square root. Exactly. And this is our derivative. So we differentiated f of xt in terms of t. Now we just need to set it equal to 0 to find what t is at the maximum. So let's say 0 is equal to 1 minus t squared, minus x over square root of 1, minus t squared, and then just over 1 minus t squared. So we have t unequal to 1 plus minus 1 because of the denominator. But other than that, we can cancel it because we multiply it with the other side. Now we can just multiply this with everybody with the square root. So let's just say u is equal to 1 minus t squared. So we can get u minus x over square root of u. Exactly. Now we can just multiply by the square root of u. So that means u is equal to u to the 3 over 2 minus x. So move x to the other side. That means x is equal to u to the 3 over 2. That means that u is equal to x to the 2 over 3. You know, these are negative numbers, so we can do all of that. And u is what's set equal to 1 minus t squared is equal to x to the 2 over 3. Move 1 to the other side, so we can cancel that. Make it negative, and then take the square root of both sides. So that means that t is equal to square root of 1 minus x to the 2 over 3. And that is the maximum value of t. So if we plug t into this, then we get the blue function actually, which is great. Now we just need to integrate this. And I'll put t into f of x and clean things up a bit. Okay, perfect. Now we found g of x. I just did plug the numbers in. And already we can cancel some stuff, like the square root cancels with this 1 cancels with this, and this is a plus. So, and the square root and this 2 actually cancel out. So a lot of stuff cancels. Let's just write it again. Is equal to the square root of 1 minus x to the 2 over 3 minus x to the square root of 1 minus x to the 2 over 3. And this is x to the 1 over 3. And because this is 1 over 3 and this is a 1, we can just minus that and we get to the 2 over 3 here. So that cancels, right? Now we need to integrate.
Okay, so I forgot the microphone, but I will do this voiceover and this will work. Okay, so first of all we pull out a square root of 1 minus x to the 2 over 3. And we get 1 from the first half and a negative x to the 2 over 3 from the second half. Then move this all to the top, so it's cleaned up again. So we need to integrate from 0 to 1 of g of x, because that's all there is to the function, right? And this is just equal to the integral of 0 to 1 from the square root of 1 minus x to the 2 over 3 times 1 minus x to the 2 over 3. Now we want to do a u substitution to get rid of the 1 over 3. So u is equal to x to the 1 over 3. And then we get du is equal to 1 over 3 times x to the negative 2 over 3. Because of the power rule, you know. Don't forget the dx, of course. We want to isolate the x, so say dx is equal to 3, because of 1 over 3, we move this to the other side. X to the negative 2 over 3, move it to the other side, it's x to the 2 over 3, and that's just u squared, right? And du, so now we can just substitute all of that in. We need to care about the integration bounds, but they stay the same. Plug in 0, you get it just 0, and plug in 1, you get 1 to the 1 over 3, that's just 1. So that's the square root of 1 minus u squared now, and times 1 minus u squared, not under square root. And don't forget the du part, so that's 3 and u squared du. Perfect. Now we want to do a trig substitution. We need sinus here, because 1 minus sine squared is cosine squared, right? And then we can get rid of some things. So sine of s is equal to u. And now we need to isolate du. Du is equal to cosine of s, because the derivative of sine is cosine, right? So we get 3 times the integral from 0 to pi over 2, because if you plug in pi over 2 for s, you get 1. And then you do sine here, 1 minus sine squared, that's cosine squared, take the square root, and that's just cosine, right? So that's cosine of s. Then this is of course just cosine squared. And u squared is equal to sine squared, but we will write it as 1 minus cosine squared, because that's easier to integrate. And the u squared is just sine, no, the u squared we already did. Don't forget du, that's cosine s ds. Now we can pack all the cosines just together. So that's 1, 3, 4. So that's 0 to pi over 2 of cosine to the 4 of s. Cosine. And then minus cosine to the 6, because there's the cosine squared. Okay, so all ds. And this is pretty easy. We can just pull out the integrals and then use the cosine reduction formula. But however, I don't do this because it's just tedious work. No one wants to see this, right? So we get 3, and then the integral is x over 16, and then the integration bounds are 0 and pi over 2. So exactly. And if you plug in pi over 2, you get pi over 32. That's 3 times pi over 32. And if you plug in 0, you get it out 0, so that doesn't matter. And that's our answer, right? That was the question. It's pretty amazing that pi shows up here too. You could probably approximate pi this way as well. But I think that's a really beautiful result. Comment, subscribe, and like, please. And see you in the next video. Bye.